So we're still at streams. Okay. So the Friday, what we did was we did the creation. So streams made up of three parts: stream, intermediate, and terminal. Okay. Now, stream doesn't do anything until you get to a terminal operation. Okay. So you have to create it. So if you want a stream to do anything, the two parts you have to have. You obviously have to have a creation part, and you have to have a terminal part. Okay, so for an order stream to operate, to do something, you have to create it, naturally enough, and you have to have a terminal operation. Okay, now, so you could have something like, I'll change this slightly. Good morning, VC. You made it in just about. It's supposed to be worse between the hours of 11 and 1, by the way. Looking it up there. Huh? Did you? Okay. Right. So, now, you can have a creation part and a terminal part all by itself and it'll run. Okay? So, for instance here, stream dot now iterate. What does iterate do? So, iterate takes a, I'm forgetting what it takes. So, iterate takes a unary operator. Okay? Iterate takes a unary operator, which means it takes something and returns something of the same type. Okay? So if it takes a dog, it's going to return a dog. If it takes an integer, it's going to return an integer. Now, so here we have said it's going to be stream, it's going to be stream of type integer. So that means that iterate is going to take an integer and is going to return an integer. What is it going to do? So now iterate takes two arguments. Two arguments it takes is what it starts at. Okay? And in this case, it's an integer. Now it can be an object, it can be any other type of object. But iterate, because of the nature of what it is, it's more often than not used with numbers. But it can be used with other types of object as well. Okay? So we start off with 1. And so what it does is it takes in an integer. So the first integer it's going to take is going to be 1. Okay? And what it does, it adds 2 onto 1. So n then becomes 3. Okay? So then it takes in 3, it adds 2 onto it, so 3 then becomes 5. It adds 2 onto it, so then then becomes 7, and so on and so forth. Okay? Starts off with 1, it keeps adding on 2 to it. Yes? Okay. Right. Now, the problem with iterate and generate, now generate takes a supplier object, just to quickly show you up here. Okay, so put my mouse over it. Right, so generate takes supplier object. Now, supplier object is, it takes no arguments, but it returns an object. Okay, so think of generate, generates a supplier. What's a supplier? It supplies you with an object. Doesn't take anything, but it creates something. Okay, consumer takes an object, it doesn't return anything. Okay, so generate takes nothing, it returns an animal. Okay, so generate and iterate, both of those produce infinite streams. Okay, both of those produce infinite streams. So what you need to do is you need to put some sort of limit on them. Okay, and there is a method called, now these are intermediate operations. All right, now you can have a stream that has nothing in it but a generate and a terminal operation. Okay, now you have that, it's going to generate it, and then you have a terminal operation that's going to execute your stream. It's the terminal operation that executes your stream. Now, the other type of operation is something called an intermediate operation. Now, an intermediate operation does not execute the stream. Okay? In other words, it's inert code. It doesn't do anything until it hits a terminal. So, if you have a stream that's made up of nothing but generate an intermediate, or if you have a stream that's got nothing but an intermediate in it, it doesn't do anything. It'll compile, but it doesn't do anything. Okay? So, a stream with a terminal operation will do something. Okay? So, you can have it generate and an intermediate operation. Doesn't do anything. I'll just show you. So if I go here, dot limit 60. Okay. Now, that doesn't do anything. Nothing. Okay. It only does something when it gets to a terminal operation. Now, there is a further thing I need to show you. It's slightly complicated, and the book doesn't introduce it, I think, until the very end of the chapter, but I need to introduce it now. Now, it's complicated, but I have to show you this. Hopefully, when I show you this, it should ease the problems you're going to have with these things. Okay. Now, just to show you, this will compile. So this is pt3 is up at the moment, just to make sure that it does. So everything works fine. Okay. Not getting any errors, nothing like that. Okay. So what this guy does is this iterates it, limits it to 60. Now, this produces the stream odd numbers. Okay. So that's a stream. It's assigned to that number. Yes? Now, it turns out every time you use an intermediate operation, that produces a new stream. All right. Now, that does make a difference. That's the main issue with streams that we're going to cover. If it takes the full day to cover this topic, I will. All right. Now, so that produces a new stream. So I'll do here. So this produces a particular stream. We call this stream A. Now, by going limit 60, this produces another stream B. Okay. Now so stream B is assigned to odd numbers. Okay. Now B comes along and it goes limit 25. That produces a different stream. C. Okay. That produces a different stream C. So odd numbers dot limit 25 produces a brand new stream C. Okay. Then we call the terminal operation on C. Okay. So each intermediate, now the term actually is if you use an intermediate operation on a string or on a stream, it effectively closes it, I think is the term. Okay. Or what it actually does is it produces a new stream. All right. It doesn't modify the stream, it produces a new stream. All right. So stream.iterate, that produces stream A. Limit 60, that produces a new stream called stream B. And it's assigned to odd numbers. If I go odd numbers limit 25, that produces a brand new stream called C. We then run the terminal operation on stream C. Okay, and it works its way back. Now, sorry? Yeah, exactly. Exactly. But you work it all out, right? Now, this is important, right? Now, odd numbers refers to this guy. Okay, this is stream A. Stream A produces stream B. Okay, so odd numbers refers to stream B. So stream B calls limit 25, which produces a brand new stream C. Okay, we then call the terminal operation on C. Okay, yep, you can get 25 over the 60 because we've already saved the 60. Okay, right, now, so each intermediate step, now it's not a terminal operation, but it is something called effectively final, because it does produce a new stream. Okay, and there's another way of putting it. When a stream is operating when a stream is operated upon, be it by a final, a terminal operation, or an intermediate, or sorry, if it's operated by an intermediate operation, it's effectively closed. Okay, it means it's effectively closed because it's a new stream. So when you go stream.iterate, you're basically finished with that stream at that point. When I go limit 60, that produces a brand new stream. Okay, stream B. Now you can put them in a row. Now I'm going slightly ahead there, but that's what I'm going to be covering today. All right, I'm going to be dealing with intermediates and terminals and something called effectively closed. All right, I'm going to show you what can go wrong. All right, and we're trying to avoid the issues that can arise. All right, we're going to try and get a good grounding in streams. If you don't get a good grounding in streams, you could be at them for months and you're still getting the same errors. So we're going to try and avoid these errors at all costs. Don't care how long it takes us to get this across to you. We're going to do it today. Okay? Now, but before we do that, so this is a stream called odd numbers, and it's that guy. Okay? So that's one stream. That's a second stream. So stream.iterate is going to keep adding 2 onto 1, and it's going to limit to 60 numbers. This one here is going to limit this to 25 numbers, and this is a terminal operation. Terminal operation which causes everything to run. Okay, it's limiting that guy. What is that guy? It's based on that guy. Sorry, it's based on this lad, which is based on this lad. Okay, it can find its way back through the breadcrumbs. If it can't find its way back, it won't. It'll give you an illegal state exception. Effectively closed. Sorry, wrong term. Effectively closed. Apologies for that. So, an intermediate operation. Once a stream is operated on, that means intermediate operation. It means it's effectively closed. Yep. Yep. Exactly. Okay. But you can still get back to A through B. Do you get me? Because A was what creates it. And then you limit A to 60. And then you limit B to 25. No. No, you only do that when you hit on the terminal operation. Okay? And the terminal operation goes, hold it, I want to limit 25. Now we can access this guy to that variable. Okay, that's a stream. So we can go back to this guy here. So odd numbers is a stream that produces 60 numbers. And then we limit it to 25. That's going to be stream C. That's stream A. That's stream B. And that's stream C. Oh no, sorry, that's not stream C. That guy is stream C. So stream 3 calls the terminal operation. Okay, now these issues is one of the reasons why you have streams in all in one line. Okay. If you don't have streams and all in one line, you're going to get an issue. I'm going to show you it. I just want to go through filter first, and then I'm going to show you the issues that could crop up. All right. Now, so for now, we can say this is a stream that creates odd numbers. We limit it to 60, then we limit it to 25, then we print them all off. Okay. None of this happens until it goes to the for each. All right. Your stream won't run until it gets to the for each. Your numbers are not created until you get to the for each. Yes? Okay. And we can take it as right that it has to go from left to right. Let's create them first. Limits it to 60, then limits it to 25. Yes? Okay. Right. Now, next thing I do is I use 25 random even numbers. Okay? So I go in here, I go stream, integer, even number, iterate, takes a unary up, it takes your starting, your seed, they call it, I think. Is it your seed they call it? Let me see. Yeah, it takes a seed, which in our case is our starting number, your starting object. Okay, we start off with the number 2. Okay, we start off the number 2, which is going to be an even number. Okay, then, so we start off with 2. Now, rather than add 2 to it each time, what I'm going to do is I'm going to generate a random number, and then I'm going to check if that number is even or odd. Okay, that is number modulus 2. So modulus 2, that's going to, so if it's even, it will have a remainder of 0. Otherwise, I'm going to add 1 to it. So let's say if this produces the random number 233. So 233 modulus 2, it's going to have a remainder of 1. Okay, so to make that an even number, all we have to do is 2, 3, 4. Okay, now iterate probably isn't the right one to use there. The right one to use there would be generate. Because iterate is for to go up in a set amount of numbers, a set amount of months, a set amount of days, a set amount of, let's say you want to produce 25 people. The first person weighs 10 stone. The second person is going to weigh 10 stone, 2 pounds. The next person is going to weigh 10 stone, 4 pounds, or so on and so forth. Okay, or it can go up in alphabetical terms or whatever. All right, now, so iterate and generate both create your strings. Okay, now the second intermediate operation, so we've done one intermediate operation, which was limit. The second type of intermediate operation is filter. Okay, now filter takes a predicate. Okay, now I created a list here of strings. Okay, and it contains the names Noel, Mary, Shelley, Colin. All right, now, so what I do here is to create a stream from any collection object, you just go simple the name of the collection object followed by the dot stream method. Okay, if you're creating from an array, you use toArray. But it's very easy to create a stream from a list. So people.stream. Now that won't produce an infinite amount of objects. That'll just produce a stream of those 4. Okay. Now I'm going to filter it out. So it takes in an object. What object does it take in? It takes in a string. So it'll filter only objects that meet this criteria. So S is going to be null. So is the length of this string greater than 4? No, it's not, so it won't be included. Is the length of the second string greater than 4? No, it's not. Won't be included. Is the length of the third string greater than 4? Yes, it is. That will be included. The next string. Is the length of column greater than 4? No, it's not. So the only one that's going to be included is Shelley. Now, if you do a limit 4, now you take the literal meaning of that. That means it can only have a maximum of 4 objects. Okay? If there's less than 4, well, that's fine. Okay? If there was more than 4, it will take the first 4 objects it finds that has got length greater than 4. Yes? Okay. Right. So this is going to just produce a list called with the word Shelley inside it. Okay? For each, that takes a consumer object. So it takes the word Shelley and it prints it out. Okay? So there it is. Produces the word Shelley. That's okay with everyone so far, yes? Right. Now we're going to come to I'm going to go to static void ex4. Let's get the other one up here. Now I am going to create a stream of animals. Okay. First of all, I'm going to create a supplier object. Supplier. I'm going to take animals. And it's going to be equal to, so I'm going to call this sup animal. So I'm going to go int num int. I'm going to say math.random multiply by 100. And then the next line, it will be turn new animal num end. Oh yeah, is equal to. Right. So that's a supplier object that generates an animal with a random age between 1 and 100. Okay. So I am going to create a stream from this supplier object. Okay, so I'm going to go stream animal and I'm going to call it ran animal is equal to stream.generate and I'm going to say sup animal. Now I'm going to go to the next line. So that will create a infinite stream of animals, yes? Okay, now if I go ran animal dot limit, I'm going to limit to 20 animals. And I go the next line ran animal dot limit 10. or I'll change it. So I'm going to limit myself to animals that have an age greater than 10. So I'm going to filter. I'm going to say it takes in a dot age is greater than 20. Right? So what have I done there? This generates an infinite stream of animals. Okay? This limits it to 20. This is going to filter the animals. It's then out of those 20 animals, only the animals that have an age greater than 20, them are the only animals you're going to have. Right? So you're not going to be able to guarantee how many animals you're going to get. Do we understand that? Yes? All right? Because I've already filtered it to 20. It's possible you might get 0 animals. Yes? Okay. Yeah. Right. Now, so I attempt to run this guy. Now, we get an illegal state exception. Okay? So, we'll work it back. So why am I getting a legal state exception? Because nothing is running, you might think. Okay? Because remember, no code really runs until you get to a terminal operation. Right? Now, stream.generate produces stream A, which is assigned to that guy. Now, ranAnimal.limit filter 20, that produces a new stream called B. Now, by doing that, ranAnimal limit 20, that effectively closes stream A, which is that guy. Okay? By running an intermediate operation on this stream, it effectively closes it. Okay? So an intermediate operation, any operation on a stream effectively closes it. Okay? So that means down here, the stream is closed. It even says it here, up here to the top. Stream has already been operated upon or closed. When you operate upon a stream, it effectively closes it. Okay? So, but the real reason is, ranAnimal, stream that generates up animal, that's a stream A. ranAnimal.limit 20, that's stream B. Okay? Soon as you perform a intermediate operation on a stream, it effectively closes it. That means that this guy here is trying to perform an operation on a stream that's already closed. I'll go through a few more examples. You can't operate a terminal either. Oh, a terminal will have the same effect, yeah. Once you operate on them, it effectively closes them. Now, here's the thing. If you reassign it, that will work. Okay, so I put in the comment here. So each operation, so each intermediate operation on a stream creates a new stream and effectively closes the stream it is operating on. Okay, so this line here, this effectively closes the stream ran animal and creates a new stream. that we cannot access after this line of code, as we have not assigned this stream to anything. Okay, so as soon as you do an intermediate operation on the stream, it effectively closes it. Now it closes it without running it. Okay. Yeah. Well, yeah, it doesn't do anything. So the, there you have just it's just sitting there and it actually does nothing. Okay. If you have that, you'll get no error, but it's not doing anything. Okay. It's just inert code. It's just like a comment. It's doing absolutely nothing. So the only way you can run that, because remember that, so this is stream A. Okay, so stream A calls limit, which creates a brand new stream B. Okay, so if you put for each after that, you're putting a terminal operation on the B stream. Okay, so this effective closed stream animal creates a new stream that we cannot access at the line of code, as we have not assigned the stream to anything. Okay, we haven't assigned it to anything, so this code is not executed. Okay, as there's no terminal operation, the code does not execute. Sorry, does not. What is it? Yeah, execute. I suppose the best thing to say. Okay, or does not instantiate. Okay, streams use lazy instantiation and will only execute at a terminal operation. All right, so this creates stream A. This creates stream B. Okay, that creates stream B. Now we haven't assigned stream B to anything, so if you attempt to put any intermediate operation after it, because that stream A is closed. Okay, so create stream B effectively closes stream A. Okay, so then we're trying to put a filter on stream A, but we can't do that because we've already effectively closed it. All right, so we've already effectively closed it, so this generates a legal state exception, as we have already operated on this stream, which effectively closes the stream. All right, and this stream, as soon as we create it, we can no longer access it because we haven't assigned it anything. All right, now a way around this, of course, is the following. Okay, so this generates a legal state. Now it doesn't matter whether it's an intermediate operation or a terminal operation. For each. They're both closed. Okay, doesn't matter. You can't do another intermediate operation on a stream that's effectively closed. Okay, so this also generates. So a terminal operation Its primary function is to implement the code, to execute the code. It also closes the stream. An intermediate operation doesn't execute the code, but it does close it. All right? Now, intermediate operation, it closes the stream, but it produces a new stream from the old stream. All right, so if you think of it that way, every time you use an intermediate operation, it's creating a new stream from the old stream. That means you can keep calling methods on it as long as it's on the same line. If you put it on different lines, you're going to get this error. That's why streams are usually written in one line. Okay, so this also produces a legal state exception, as this stream has already been operated on and is effectively closed. So if you have code like that, here's the thing, you should never have code like that. All right, because there is no way that that code can run. When you have code like that, that code will never ever run. All right, so the only reason you'd have that is if you intend to come back to it at some point in the future. All right, and put your for each in here. Now that'll work. Oh fuck, hold on. All right, this slide down here. All right, it's fine. Okay, now, but I'm going to take that guy out. Now, I'm going to redefine ran animal again. Now, all we need to know is that produces a stream that is capable of producing an infinite amount of animals. All right, now that itself does not produce the animals. Okay, it's capable of producing an infinite amount of animals. Do we understand that? Yeah, just like, and also this one here, that's capable of producing 20 animals from that stream. That's the way to read it. Okay, so this guy is capable of producing an infinite amount of animals. This guy here is capable of producing 10 animals from this infinite amount of animals, from this object that has the potential to produce an infinite amount of animals. All right, so the streams itself don't contain the animals. It's only when you call a terminal operation that's what creates the animals. All right, so these are an animal producing factory. This is what puts the limit on the animal producing factory. What actually produces the animals is a terminal operation. Okay, so that's what streams are. Streams are the potential to make something, and only the terminal operation is actually what makes them. The intermediate operations is conditions. You don't want to produce an infinite stream. You don't want to take all the items from a list of 1,000,000 objects. You filter them out. You do all sorts of shit to them. Okay, now I create an object that has the potential to create an infinite amount of animals. All right, now if I go on the next line, equal to, yeah, no, well, when we come to that, it can make a difference, all right, but it's just to do with the results that's produced. It'll work though, either way. Okay, so ran animal dot limit I'm going to limit it to, actually I'll filter it first. I only want animals with the age greater than 20. Um, oh, A.age, sorry. Right. So that's going to be animals that are greater. Now, when I come to the, in different orders, I'll do this, but I'm just showing you a different thing at the moment. All right. So now, and I do this last one. Ran animal is equal to ran animal dot limit to 5, and then print out 5 animals. Then I go ran animal is equal to right. Now, so just to show you, this works out fine. And let me just see. So I have 5 animals. His age is greater than 20. His age is greater than 20. That's our second animal. His age is greater than 20. That's our third animal. That's our fourth animal. Shouldn't we have 5 animals there? 1, 2. Oh yeah. 3, 4, and 5. Okay, so 5 animals created. Yes? See that? And also you can see here, constructors call more than 5 times. Okay, the constructors call more than 5 times because it's created more than 5 animals. Because it might have created an animal with an age of 15. I haven't put any block on it. Okay, I haven't said here I don't want any age when I was creating the animal up all the way up here. I haven't said I want the age to be greater than 20. Okay, so the constructor could be called more than 5 times. See it here? I obviously created an animal there at that point with an age less than 20. 20 or less than it. I am Iggy. Okay. Now, so just to explain what's happening here. So stream.generates sup animal. So this creates stream A. Okay, and stream A is assigned to ran animal. Now the next one that creates stream B. And it's assigned to ran animal. The next one creates stream C. And it's assigned to ran animal. Okay, it's assigned to ran animal. Now, so ran animal is now stream C. So when I go here, this is calling for each on stream C. Okay, so to read the correct, so I'm going to substitute all so okay, because right, the generate function takes a consumer object that creates animals at random ages. Okay, so let's say it produces, in this case, it's going to produce one animal with an age of, I'll write down the exact ages. So it's produced an animal with an age of 30, an age of 28, Now it's probably different on yours. An age of 91, an age of 58, and an age of 90. Now, the thing is, when I'm generating the animals, I haven't put any limit on the age. Okay, so I can see here there's a constructor called. So obviously what happened there is an animal was created with an age 20. So I could have an animal with an age of 18, but I filtered that out. Or sorry, I filtered it out here. Okay, so it produces enough animals, it limits them to 5. So it has created 6 animals. Okay, and it takes 5 of those animals out. All right, now, so as I said, so ran animal, here it refers to, first one is A, second one is B, third one is C. So this one here, it's C that's calling the terminal operation. Okay, so stream.generate that generates it. So B is equal to ran animal here refers to A. So A dot filter that closes A. Okay, closes A and assigns the new stream to ran animal, so that becomes B. But A is closed. Next line, ran animal is equal to ran animal limit. So ran animal here is B. So ran animal dot limit creates a new stream, C, assigns it to this guy here, but it also closes B. So on the last line here, so C hasn't been operated on yet, okay? Because this is what creates C. That's what creates C. So then when I go ran animal dot for each, that closes C. It closes and it executes, and it can make its way back. It goes all the way back, and it starts off stream generate, goes down all the way until it gets to here. That's the way it works. Okay, so if you know when streams close, it makes your life a lot easier. All right. Now the easiest way to do that, believe it or not, is this way. You just go stream generate subanimal dot filter oops, sorry. Now, so I can put each one of these on a separate line. And if you want to, you can put that on its own separate line as well, but you'll indent it. Okay, so that's one way to write them. You can write them on one line, or you can write them so each method call is going to be in its own separate line. Okay, so this produces stream A. Stream A calls the filter intermediate operation. So it closes A and it produces a new stream B. Okay, now B is a new stream and it calls limit, which produces another new stream C and closes B. So limit dot, there's a dot there, So C dot for each. That also closes C, but it's a terminal operation, which means it executes everything. Okay, it executes from the top, and you read just all the way down. Okay, so I don't know if they're going to ask you this in the exam, but if the question was asked, how many streams are produced in that line code, the answer is 3. Okay, how many objects are created in that stream? Answer, can't tell. It's impossible to know. All right, because I don't know how many animals are going to be produced by this guy here. It could produce 4 animals that have got an age less than 20. It could produce 1 animal less than 20. Okay, so if they're asking you a question, how many objects? You'd have your 3 streams, which are objects, plus whatever amount of animals are created. You can't guarantee how many animals could be created. Okay, you'd have to change the code. You'd put something here in filter, for instance. That's one way of doing it. Okay, now, but that produces stream A, and stream A calls filter, which closes stream A and creates stream B. Stream B then calls limit 5, which closes stream B and creates stream C. Stream C calls a terminal operation, which causes our code to run and also closes C. Is that a bit clearer what I'm talking about? Okay, so that's why, in reality, that is easier than that. Because you don't have to worry about, is my stream closed? If you use that sort of syntax, you have to make sure each time, well, hold on, is my stream closed? If your stream is closed, you can't do another operation on it. Jeez, that's bad outside now, by the way. Fucking hell. Yep, you can. But remember that this is a different stream for each line. Right? Oh, yeah. The very last one can be a stream, and you can call the terminal operation on it. Yes. Yeah. I'll put it in as a method. Okay. Now, that's fairly important. Is it examinable? I don't know. I don't care. Because you need to know this. You need to know each time you operate on a stream, you close that stream and you create a new stream. All right. If you know that, then you're okay. All right. Now, the book doesn't mention that until the very end of the chapter, and they just kind of barely mention it. But to get to use streams, you need to know this. That each step of the way is creating a new stream. That creates stream A. This creates stream B from stream A and closes stream A. This creates stream C from stream B and closes stream B. Stream C has a terminal operation. That means it closes stream C, but not before it executes the whole shebang. Any questions on that? No? So if I did this, okay, ran animal stream filter, and if I go ran animal dot for each, I'll just say Will that compile and print out? It will. Okay, because that guy produces stream A, this guy produces stream B and closes stream A, this guy produces stream C and closes stream B. So ran animal is stream C. So we just have stream C hasn't had any operation on it yet. So we have ran animal dot for each. That runs our code and closes C. Okay, that's the way to read it. Is that okay? Right, so I'm going to move on to the other terminal operations. Cancel there, and see me. So I'll put in a comment here. So this produces a new stream A, which is assigned to ran animal. This produces a new stream B from stream A and effectively closes stream A. This produces a new stream C from stream B and effectively closes stream B. And this one here executes our stream, executes stream C, which causes all our code, which causes all our stream code to run, and closes stream C. Okay. Now, if you wanted to, you could have 3 different stream variables there. You could call that ran animal 1, ran animal 2, ran animal 3. All right. But that's not advisable. Because if you have 3 different streams that are 3 different parts of the one stream, all sorts of mad shit can happen. The easiest way to use a stream is that way. Okay. I don't know what even bother assigning them to something. Okay. So what they're used for creating things quickly and easily. All right. Because for start anyway, you can't assign that to anything. Why? Because for each returns void. Okay. If you do want to save those objects, all you have to do, here's a good question, right? So I'm going to bring this down here. Now, this creates 5 animals. So, creating 5 animals. We'll make it 7 animals. Okay, so this creates 7 animals. So here's a question. Is there any way now, so I can't assign that stream to anything. Okay, why? Because for each returns void. So if I go red animal, which is a stream, that's going to give me an error. Why? Because for each returns void. Okay, so comment out. This guy. Now, you can't assign this to anything. So, because remember, the last method call, that's what determines what the whole lot of it is. All right? So, all of that line produces void. okay, as the final method call is what determines what the line of code as a whole returns. For each returns void. So this cannot be assigned to any variable. Right, so the question is, how do I save those animals? Because the way they are at the moment, it creates 7 animals, it prints them off, and they're gone. Is there any way I can save those animals? Of what? There's an easier way. Well, right. So remember, for each is, so I'm going to modify the for each. Okay? So in this case, it takes an animal object and it returns nothing. Now, the thing is, you can put anything you want inside here. Okay, you can put anything you want inside here, including, let's say I create a list of animals. Woo! Well, it looks like we're staying the night, folks. Break out the biscuits. We'll have a little campfire. Okay, so this creates a list of animals. It's empty. All right, now remember, you can access variables inside a lambda as long as they're what's something called effectively final. Okay, now I haven't reassigned this list to anything, so that means yes, it is effective final. You could go like this. Effectively final means you can put final in front of it. Okay, now, so what I'm going to do is I am going to add each time I'm going to print them out. Okay, so it prints off the animal. The next thing it does is it adds that animal to the array list. Okay, so what we can do, we can use a for each to add them to an array list. Now there's also a method called collector, right? There's also a method .collector which will create an array list, a queue, a set for you as well. Okay, slightly different for hash map. Oh Jesus, they're difficult with hash maps. All right, so what is this doing? This here, this is generating a 7 animals and then assigning, or sorry, and then adding each animal to a array list of animals. Okay, and to prove that it does have those animals, I'm going to say animals is there it is, age is 30, and they're all animals with an age greater than 20. Now, is that okay? Right, so that's just showing you what to avoid with streams is that at each point in the stream, it creates a new stream, and each intermediate operation is effectively closes the stream. It creates a new stream from the old stream, and it closes the old stream. So stream.generate creates a new stream. Dot filter closes that stream, creates a new stream. Limit 7 creates a new stream, closes that stream. For each is a terminal operation. It causes all our code to execute from the top to the bottom, and then it closes that stream. Okay, so always remember that the intermediate operations are closing. Now, the way to get around, if you were assigning a variable to it, that's where the problem happens. Okay, I create a variable here called ran animal, then I go ran animal.limit. That creates a brand new stream, but it closes that stream. So that means I can't call anything else on it. All right, so you could argue that streams is probably the only place really. Usually when you're using anything in any programming language, you assign it to something. Streams are slightly different. It's probably the only circumstance where you don't usually assign a stream to anything. You just use it to create your objects. You use it to get all your information from a database, create your objects in the database, and maybe even save them back to the database. Okay, so any questions on that? No? All right. Okay, so we will go on to static void ex5. Now, so we're going to do the rest of the terminal operations. Now, what are the terminal operations? So I'll go up to the very top here. I don't have them written. Where do I have them written out? I have them in main, I think. There either. Hold on a second. Okay, I don't have them written out. So give me a second. I'll type them out for you. Oh, no, there either. I'll put them at the very top. So here's your terminal operations. Right, the ones we've done so far. We have done toArray. We've done for each. Okay. Now, the first types we're going to do something called reductions. Now, the reductions we do are count, min, and max. I'm going to leave reduce out of it for now. Okay, that's a different thing. Now, what a reduction is, it's a stream produce multiple objects. Okay, what a reduction is, it produces a single value from multiple objects. That's what a reduction is. So a count, what is that going to do? That's going to produce the amount of streams produced, or the amount of objects reduced in a stream. Min is going to get, now min depends on if you've overridden the equals method. Okay, min depends if you've overridden the equals method. If you haven't overridden the equals method, well then your result is going to be all over the place. All right, so if you have a stream of strings, let's say A, Z, B, okay, the minimum of those three is A. The maximum of those is Z. Does everyone understand that? Yes? if you have a series of integers, let's say 110, 90, 400, the minimum of, so if our stream produces those three numbers, dot min on that will give you 90, dot max on that will give you 400. Now they'll only work really on objects where you have overridden the equals to method. Okay, if you haven't overridden the equals to method, then it tries to order them by their name or some shit, I don't know. Okay, we're going to be doing it anyway. Okay, so first ones we're going to be doing, now I really should put this up at the top. Yeah, yeah. So these are terminal operations. So I'll put this at the very top of the file. So it's the list of terminal operations. Now we've already done to array, we've already done for each. So first ones, so we're going to do, these are reductions. So I'll put it in here. So what are reductions? So reductions are a special type of terminal operation where all the contents of the stream, it's not really all the contents of the stream, where all the objects created by the stream are combined into a single value. Now, so first one we're going to do, and the easiest one. Now that single value could be an int, okay? Hold on, let me just see, count. Give me just 1 second here. Okay, so single value could be a primitive, a number, long, for instance, or it could be an object. All right? The maximum dog is going to be an object. Yes? The maximum number, now max and min are longs. All right? Max and min are going to be longs, regardless whether they're integers. Yeah. Okay. Get that in a minute. Okay. So single value, it can be a primitive or can be an object. Yes? So it's reducing it to a single value. So count, the first one. Now, what it does is counts the amount of objects in a stream. Now, and it returns a long. And the reason it returns a long is because the stream can create billions of objects very quickly. All right. If it was an integer, you're only limited to 2.4 billion or 2.1 billion, isn't it? Something like that. All right. So you make it a long because you can produce tens of billions of objects like that. Okay. So very simple. Let's put in here. Count is a reduction. So I am going to create a string. And I am going to go integer. So I'm going to go stream dot generate. Now I am going to, so it's going to take a, oh, I haven't actually given, thanks. Num stream. Okay, so now generate takes supplier object, means it takes something and returns. I'm going to return int math dot random multiply by 100 and go there and go dot limit 15. Now, so that creates stream A, which in turn creates stream B. So that means stream A no longer exists. So stream B is a new stream and it's assigned to num stream. Yes? Okay. So two streams are actually created there. All right. So stream A is created, which creates stream B. That means it closes stream A and assigns it. So that produces, now that's very simple. So would you use count in this one? Not really, but we can prove that it is. So amount of objects created, we just go stream num stream dot count. I'm going to run that to main ex5. $15. Now you don't read, so count is a terminal operation, number one. So that means it's been operated on, it's been closed. So that means you can't do anything else with it. Let's say num stream dot for each, for instance. Oops. Returns void, you can't put in print statement. So we get an illegal state exception. Okay, so terminal operation, this one here. So this executes the code and closes the string, or closes the stream. All right. Now, so you wouldn't really use count for something like that because you know what's going to happen there. Okay. Now, you'd use count in something like this. So if I go num stream and I go is equal to stream dot generate, do this shit. And dot filter, and we'll say I, we'll say I greater than 40. Why is that not working there now? Give me a second, filter. do the other way around, sorry. I'm going to limit it to 20, and then I'm going to filter to only numbers that are greater than 50. And then I'm going to go num stream dot now question, how many numbers is that guy going to produce? Is it 10? Is it 20? Is it cannot say? Cannot say. Okay, because it's the way it's written. Okay, so here's an example. One of you asked there before, does it matter the order when you put them in? You're going to get a result, but you're going to get different results. Now, by doing this, you're almost positively not going to get 20 numbers. And the majority of cases, there is going to be cases we are going to get 20 numbers. But in the majority of cases, you're not going to get 20 numbers. Because the way it goes is, it limits these to 20 numbers. Then it filters out the numbers that are greater than 10. Actually, we'll make that greater than 50. Okay, so you cannot say. So in that situation, then you would go, there's only 7 created. Next time I run it, 11. Next time I run it, 6, 13, 10, 7. Now, if you run it enough time, you're going to get an average of 10, by the way. Okay, you are going to get an average of 10 because there's 100 numbers created. That's just the way it works out. All right, so the order, to answer your question, does matter. Okay, now but remember that generate produces a stream, a new stream. Limit produces a new stream. Filter produces a new stream. Now count produces a long. So you can't call any methods. So it produces a long. That's what it produces. It doesn't produce a stream. Okay. So what is this here? I'll explain this one. So this now this doesn't produce the numbers. This guy does. Okay. So all of this only runs when I go to the terminal operation. Okay. So this generates 20 random numbers and then filters out those 20 numbers to only numbers greater than 50. Okay, now the numbers are not created at this point. It's only at the terminal operation are these numbers created. Okay, so the numbers are created down.
Please ring extension 277. Ivan, please ring extension 277.
So again, this guy creates stream A, which is used to create stream B, which closes stream A, And this guy is used to create stream C, which also closes stream B. So stream C is what's assigned to num stream. So this guy here, C.count, it executes all of our code and it closes stream C. Is that okay? Right, so count is easy. That's the best way to describe it. Yeah. Right, so, well, here's a couple of things, right? You couldn't put in count in 374, right? Because count returns a long. You can't assign a long to that guy because that guy is a stream. Okay? So the only thing you can assign that full line to is a long. Right, I'll actually rewrite this line. So that is fine. Okay? Now I go long lnum is equal to this guy dot count. Okay, so dot count returns long. So dot count returns a long, which can only be assigned to long. Can you assign a long to a double? Jeez, I forget. I think you can, can't you? Yeah, I think you can. No, you can't. Okay, you can assign an int to it, right? But not a long. You can, right? So you can. Okay, you can, of course. I just want to make sure, right? Count returns long, which can only be assigned to a long. Okay, so that guy produces a long. Is that okay? Now, R double, yeah, R to a compatible data type. So a long wrapper or a double, as a long can fit inside a double, but not a double wrapper. Okay. Now, all right. So that is count. Now, the next one I'm going to do is min and max. And min and max, they have their both methods basically work the same way. Actually, I'll probably do another one. I'll do a separate one. So I will go static void ex6. No, I'll keep it the same one. So I will go min and max. So I'm going to go numstream is equal to stream dot of. So I'm going to put in streams 2, 3, 4, 56, 11, 2, 6, and 99. Okay, so min. Give me a second here now. I have something going out here. Bastards. Comparator. Bastard. All right, so now min and max, it turns out, sorry, I was thinking of something else. They're not that easy at all. Okay, now make sure I have this done right. Now, min takes a comparator, right? What does min and max take? So here it goes. Min, we'll do min first. Min method looks like following. So min method signature looks like this. Okay, we go, it's an optional type T. It's called min. It takes a object. It takes a wildcard object, a super T. Yes, Jesus. Okay, and that's comparator. Now, first of all, you can create an empty stream, number one. Okay, also, you can also create a stream that's infinite. Yes, prove you can create an infinite stream. If I go stream dot iterate, I start off with 2 and I'm going to add 2 onto it each time and I'm going to multiply it by 2. Right, and then if I go stream.iterate for each, now what's that going to print out? An infinite. Okay, let's find just to show you that it is. Starts off with 2. Let's give me note. 0. So it starts off with 2. Why is it giving me 0? Let me just see. Plus 2. That should give me 2, 4, 6, 8. Yeah. Okay. So off she goes there. Right? She's going merrily and merrily along. Okay. Now, so with stream iterate and stream.generate, by default, that they produce an infinite amount of strings. Question: what's the minimum of infinite? There isn't one. No, because it goes. What's minus? What's the maximum of infinite? There isn't. There isn't a minimum of infinite either, because it goes down minuses. So that's why it has to be optional. Okay. So so remember we're doing this. Oh, shut up and just stop it, would you? I wonder what happens when we get to billions. It's at 900 million, 99 billion. So that's a billion. I'll just leave it running and see what happens when it gets to 2.1 billion. Now, come on, keep on going. Right. Now, so that's why when you're using min or max, they both return an optional. Okay, so it keeps on going. Min methods, so has to be optional as if dealing with an infinite stream, then there is no max or min. Okay? So it's optional of type T. So that means whatever your string is, if it's a string of integers, then type T is going to be an integer. If it's a string of dogs, then type T is going to be a dog. Okay, it does go beyond 2 billion, 2.1 billion. Strange. Okay, it keeps on going. Now, I'm presuming what's happening there is that it's storing it as scientific notation. I presume. Okay? Because there it's gone beyond 2.4 billion. Or is that? No, that's not 2. That is 2. You're right, Seth. I don't know what happens. But you know what? It doesn't really matter either. Okay? Now, so, and it takes something of type T. Now, so it can take a object of type integer or a superclass of integer. It can take a dog of type dog or a superclass of dog, but not a subclass of dog. Okay? That really doesn't matter, that part. All you have to know is that whatever that type is there, that's going to be the type there. Yes? Okay. Right. Now, it only works with either it only works with objects that implement the comparable interface. Okay? It only really works with items that implement the comparable interface. Let me just see. Right, so what do I mean by that? Right, now integers implement the comparable interface, yes? Okay. If we look at the animal class does not implement the comparable interface. So that means you can't use max and min with animal. Do you understand that? Now, I'm going to show you how to work it with integers, and then we're going to create a new class. What did I call it? It was rat. And we had rat implement the comparable interface, and you can use max and min with that. Okay? So, we're going to go down along here. Stream.iterate for each. That produces an infinite amount of strings. Okay, so I'll say that here. This produces an infinite stream of integers, so there is no max or min. Okay, so comment that out. So I am going to create an optional variable. All right, I'm going to produce an optional variable, numstream. So it's going to be optional. It's going to be integer. I'm going to call it mini is equal to numstream dot, and I go min. Okay. Now, so what is going to take in? So what we're doing is we need to compare. If you remember, so min takes a comparator. What's a comparator? A comparator is it takes in two objects of type. What of two objects of type? It takes in one, in two. It's going to take in two numbers at a time, and it's going to compare the two numbers to each other. All right, that's how it figures out which one is min, which one is max. So in this case, it's going to go min takes in two numbers, numstream, and we go in one dot compare to in two. All right. So what is that doing? That takes in a comparator. And if you remember, a comparator, a long time ago, takes in two objects. Now, the integer class implements the comparable interface. Okay, so the integer class implements the comparable interface, so it has a compare to method. Okay, it has a compare to method. So what that does is it compares each one of them. So it sees that 234 is bigger than 56, so it marks 234 as the biggest. Then it compares 234 with 11. Oh, sorry. It so we're doing min. It checks. Bring up my pen. My pen gone. It's the last thing we do then before lunch. So we're checking for min. It matches 234 against 56. It sees that 56 is smaller than 234. So now it marks up 56 as the smallest. It checks 56 against 11. It sees that 11 is smaller than 56, so it marks 11 as the temporary smallest. It checks 11 against 2. It sees that 2 is smaller than 11. It marks 2 as the smallest. It checks 2 against 6. It sees that 2 is still the smallest, so the marks 2 is the smallest. It checks 2 against 99. It sees that 2 is smaller than 99. It's the last method, which means that 2 is going to be the smallest number. That's the way it works. Max works the other way around. 234 is marked as the temporary max. It checks it against 56. It sees that it's still the biggest. 234 checks it against 11. It sees that 234 is bigger than 11. Marks 234 as the biggest. It checks 234 against 2. 234 is bigger than 2, so it matches 234 still as the biggest. It checks it against 6. It's bigger than 6. It's bigger than 99. All of them are checked, so we can say that 234 is the max. Okay? I'm going to do more of that when we come back from lunch. So it's not as windy as it was. All right. So I will stop that recording. I'll keep the share on. As far as I know, that should be okay.